Hello students, this is Mr. Fox, and today we're going to show that our example that we did yesterday, the same process will work for an example which has a leading coefficient that is not 1. So for step 1, we want to make sure that our expression is in standard form, and luckily for us it actually is. So we can just say 3x squared minus 11x minus 4. Very good. Now step 2, we want to find the product of the leading term and the end term. So we say 3 multiplied by negative 4 is equal to negative 12. All right, for step 3, we want to find two numbers which will add together to make negative 11 and will multiply to make our product. So our product was 12, negative 12, and let's just think of a couple different ways that we could factor, right? We could do negative 3 and 4, or I could say negative 12 is 1 and negative 12, right? Or I could say that negative 12 is negative 12 and 1. So the reason that I took these second pair of steps here is because it becomes obvious what our answer should be, right? We're trying to look for two numbers that multiply to make negative 12 and add to make negative 11. So if I say 1 plus negative 12, that's what gives me negative 11. So step 4 is that we take our original expression, 3x squared, and now instead of writing negative 11 like we did up here, we're going to rewrite that as two different terms that will add to make negative 11x. So I'm going to say minus 12x plus 1x minus 4. All right, so now this expression can be broken up into two pieces, and I'm just going to go ahead and rewrite this in blue. And step 5 is that we're going to factor by grouping. So if I group this, here I see that I can pull out 3x. And when I pull out 3x, I'm left with x, and then 12 divided by 3 is negative 4, is x minus 4, plus over here, I see that the only thing that can come out is a 1. So I'm left with 1 and x minus 4. And so my final answer will be 3x plus 1 multiplied by x minus 4. And there we go. Those are the two factors. So what about something that isn't a trinomial? Well, we can see in these two examples that is the case. So let's start with example 3. Example 3, we have these numbers here. And remember, we have the sum, I'm sorry, not the sum, but the difference of squares. So if I'm looking at 16x squared, and I only have two terms, maybe, and I notice that I have my minus in here, this might be a difference of squares. So let's think about what that would be. Well, remember, difference of squares says that a squared minus b squared is equal to a minus b, a plus b. So what would my a be in this case? Well, let's think about it. 16. Is 16 a perfect square? The answer is yes, right? The square root of 16 is equal to 4. So that is actually a perfect square right there. So then I can see that if I say maybe 4x plus 1 and 4x minus 1, that will probably be my answer, right? Because 1 itself is also a perfect square. And if we multiply these out together, right, in our box method, we've got 4x plus 1 and then 4x minus 1. So you would get 16x squared. you would get 4x, you would get negative 4x, and you would get minus 1. And we see that here, these two terms will cancel out, and we're left with 16x squared minus 1. And that was our original answer. So that's a good way to check and see if you've done the right thing. Now, additionally, let's look at this next problem. Well, first off, is this a difference of squares? Well, let's go ahead and factor these, right? So x to the fourth, I could break that down into x squared and x squared. So yes, indeed, x to the fourth, the square root of x to the fourth, is just x squared, because x squared multiplied by x squared will give me x to the fourth. Now what about 81? Well, 81 is 9 times 9. So again, 81 is also a perfect square, with my a being x squared and my b being 9. So I can rewrite this expression as x squared minus 9 and x squared plus 9. And if I wanted to go ahead and check and make sure that example 4 is correct, the way that I did for example 3, then I can do that as well. Remember, use your square method. If you have any questions, please ask me, and have a wonderful day.